Real-time pressure, but please give a warm welcome to Wiktor, who's going to tell you a little bit about distributed event stream processing. So really stay tuned for that, and I hope to see you next time, hopefully before the end of the vacation, but if not in September. Have fun, feel free to write on the meetup page, and thanks very much for coming.
First question, do you hear me? The back rows, do you hear me now? Alright. Now it's better? Yeah. Awesome. So, as Jan said, my talk is about distributed stream processing with Apache Storm. So, first let's start with a few words by myself. I'm Wiktor Kierzek. I work as an application security engineer at CurrencyOne. If you've never heard about CurrencyOne, we do currency exchange online. So it's Internet Mercanto and Volte.ml. If you would like to reach out to me, here's my email address and my account. So, what is real-time event stream processing? So, it's all about analyzing events in real time. So it's about deriving conclusions from the events, taking some actions. You can think about it as a real-time UI, which gives you the possibility to react immediately to the things which are going on. This is very interesting because what you can use it for, you can use it for monitoring all the things. You can use it for monitoring the systems and their security. You can analyze the traffic with it, and you can take immediate actions if something bad is going on. I think the best thing is to say what companies actually are using it for. So here's a few positions from Portabyte's list on Apache Storm page. The one which is for me the most interesting is the Spotify. I know if you knew that Spotify use Storm for all the music recommendation, for monitoring, for analytics, and they actually have like 1,000 topologies. So it's a lot of analyzing. Which is the second, which is I think very interesting, is Spider.io. They use it to identify any suspicious and undesirable website activity. So they're actually trying to detect any attacks on their websites with Apache Storm. The third, which is for me very interesting, is the fourth one, which analyze all the tweets which are going on and have some keywords or hashtags, and create some alerts. So imagine that you have a company and your competitor is about to release a new product. So you want to run some marketing campaign against this product, but you don't know when he will release it. So you just set a monitoring on his Twitter, on his Instagram, Facebook, and try to get some conclusion when the product will be released, and immediately after it, you will run a campaign to get it. So, how you can do the real-time event processing now? There are several frameworks ready for that. Of course, Apache Storm, but also Spark Streaming, Samza, Flink, Kafka Stream. So there's all of them. Those are quite interesting, and I recommend take a look on them, or those four. But this is not the end. There's also something like data stream processing, and here are the most used libraries for it. And what is data stream processing? It's about moving large amount of data from some inputs to the outputs, and you can do some simple operations while moving those data, like normalizing the data, adding some new fields, enriching the data. So it's commonly used for moving the logs from files to Elasticsearch, or moving some data from one QPQ to again Elastic to some databases, and it's widely used with Apache Storm. So first we have the data stream processing, which enrich the data, normalize it, put it on the queue, and then Storm or other event stream processing frameworks are getting the data and analyzing them. Next thing, which is also very small, actually is a subset of systems, the complex event stream processing. Those are very heavy tools. Those are the most commonly used examples. And what is complex event stream processing? It's complex event processing is about deriving conclusions. So let's take an example. We have 3 events. You have an event about church bells ringing. You have a second event. There's a guy with a tuxedo on him. And you have the third event. There's a rice flying in the air. So you can derive a conclusion that there's a wedding going on. And these are the main difference between the complex event processing and real-time event processing is the time, because complex event processing is always offline. It's after it happened. And what's very interesting about it, in most cases, in most applications, in complex event processing, you have something like a time window of events. So you don't analyze event by event, one by another, but you have a time window, and you can even write an SQL query on this time window. But getting back to the event stream processing, the frameworks which may be used for it, let's go through those 4. The first one, Apache Spark Streaming. It's I don't know how many of you know the Apache Spark. So what they did, they actually tried to make it real time. It's not real time because it uses micro batches, so its latency is more than a second, so it's near real time. What is very interesting about Spark Streaming, it has exactly once delivery. It's in some systems it's very important to have it. It also supports all the Spark libraries like SparkML, GraphX, so you just have all these things out of the box, which is very important. And you can write the JavaScript and Python if you need. Then we have the Apache Flink. It's actually very new. It was released, I don't know, maybe 2-3 months ago, and it's like taking Apache Spark Streaming one level up. So it has, again, micro batches, but also event streams. Exactly once delivery. Some Flink.ml and Jelly are also similar libraries which you have in Spark Streaming. But it has latency in milliseconds because of the event stream. And what's very interesting is data stream API. So you have out-of-the-box map, you have grab by, you have joins or streams, so it's very convenient to use. Then you have Kafka streams. Actually, this is the newest one. It was released a month ago. What is Kafka streams? It's very simple. The full code base of it is like 9,000 of lines, so it's very small, very lightweight. It has, only the latency is milliseconds. It's event stream. It also has all the necessary functions like windowing, joins, aggregations of data streams, so it's very convenient. But it has low-level API, so by low-level API, I mean that the programmer has to deal with the data, the raw data. In Spark Streaming, you can run some higher level code on the data. And next, the last one, which I would want to talk about, Apache Store. So what it has all 3 methods of delivery. It has at least once, at most once, and exactly once. The exactly once is with Apache Trident. Apache Trident is like a level of abstractions built on top of Apache Store. What is very cool about Store is that you can use Java closure, Scala, Python, JavaScript out of the box, and if you would like to use another language, you can, because Apache Store can run any application and it will, as a new process, and it will communicate with the new process using the standard output and input, and communication will be in JSON, so you can use whatever language you like. What is also cool about Apache Store is the distributed RPC. So you can create a a Storm application, a Storm topology, which will do all the analysis. And you can just ask the topology, hey, Storm, I have this data, just please analyze it and give me the result. You cannot do it with all other libraries. All the other libraries just will get the data from the inputs and just put the results into the output to the database, to ASICs or whatever. You'll have to go to those outputs and find those results. In Apache Storm with distributed RPC, you'll just get the results. It's like synchronous ask to Apache Storm. If we want to compare all those, I think this graph will tell you a lot about how it is. So, Flip is the most powerful, I would say, with all those data stream API, with all those libraries. It's most powerful, but it's very complicated and very heavy. Same with Spark. Kafka Consumer, I didn't talk about it. Kafka Consumer is the simplest approach to event stream processing. It's like having a Kafka queues and just taking message from Kafka queue, doing some process and putting the process message back on the Kafka. So it's the simplest solution. It's very simple, but it doesn't have any fancy functions. And Storm is somewhere in between. So what are the basic concepts of Apache Storm? These are the 5 keywords which I'll just explain to you. So first, the tuple. Tuple is the core unit of data in Storm, and it's just an ordered list of values. The values, the only limitation is that those values have to be serializable. That's all. I think the interesting part is that there is no field names in tuple because of the optimization of data which is transferred between the nodes. But you can name the fields, but you have to do it in a code. I'll show it later. Then the stream. Stream is just a sequence of tuples. Simple as that. And then spell. This is our input. This is the source of streams. This may be something what read from the IMQ queues. It may be a file log, which is read by something. So this is the thing which actually feed your topology with data. Then the bolt. I know where they took their names from. Bolt is a thing which implements the core functionality. This is the thing which actually processes the messages. It receives a tuple, and it can also emit a tuple to another bolt. And then the topology. So topology is the thing which defines the data flow in your application. It's a distributed acyclic graph. Acyclic is very important because you cannot create cycles in other frameworks. You can do cycles in Samza and Spark Streaming, I suppose, and Storm no. So it's the only limitation. And the last thing is string grouping. What it is? If we take a look here on topology, there is some connection between the spots and bolts. And what is the string grouping? It's a thing which defines how the data is transferred from spots to bolts. There are several methods. So first, shuffle. It means that if many bolts read from the same spot, like here, the shuffle means that those tuples will be delivered to the bolts randomly. So just a random grouping. Then fields grouping. Fields grouping gives you the possibility to ensure that the tuples with the same field value will always be routed to the same tasks. It's very important if you want to analyze all the events which are from one user, for example, or from one IP. And then all grouping, I wouldn't recommend it because it just sends everything to everywhere, so it's not very useful. So the Storm architecture, how it looks like inside under the hood. So every communication is held by zookeeper. You have two types of nodes in Apache Storm: the Nibus, which manages the topologies, which is about sending the topologies to the workers, and the workers actually are supervisor. The supervisor is a node which runs the jobs inside. So let's move to the examples and look how it actually looks like. Maybe the code is too small. So the first example is Twitter. It's not. So what this topology will do? It will read the data from the live data from Twitter. It will look for tweets with defined names, defined keywords, and it will just analyze what are the most common hashtags in these tweets. So let's first run it, and we will take a look how it works. So how we start the topology? I think the easiest part for local topology is just to run it. I know that. Do you see the text, or just too small? Too small. Okay, so let me just quickly change the configuration. Here, I think it should be okay. It's okay now, or bigger? That's a bit bigger. That's the 30. Alright, so let's start it. Let's start again and we'll see how it works. And it works. Right. So now the topology is starting. So you have two modes of operating the Apache Storm. You have the remote clusters, and you have the local clusters. In the remote, I think I mean a cluster of several servers somewhere else. And by local, you just run a whole topology on your computer. So it started, and as you now can see, there are some events flowing in. Every new line means that someone posted a new tweet with keywords which I defined. And here you can see that the most common hashtag for now is Python. Then we hit the jobs, so just analyze the live tweets, and it's actually live data because, as I said, every new line is a new tweet with defined keywords. So let's take a look how it looks like in code, just real quick. So if you want to do something with it like this, first you go to the source of data. The source of data is here, it's code. How it works? Let's go to this one. So the whole API of this code is this method, next tuple. It's executed by the topology, and it just takes another tuple from the source. And all you have to do is just call the emit method, which will relay a new data, a new tuple to the topology. So simple as that. And then how to analyze the data. Let's take a look on some of the bolts. For example, the filter bolt. Filter bolt just checks if the value of the field, of the defined field, is in a whitelist, in a list of values which we want to pass further. So again, we have a simple method called execute, which gets the tuple and just decide if it wants to pass further or not. So again, just check the value here and emit the data if we want to or not. So as you can see, that the API of spots and bolts is very straightforward, very simple. Any questions so far about the code, the API? No. So let's go further. So now the topology. How we define the topology? So let's take a look on the code. Here's the full topology of analyzing the tweets. So we have something called topology builder, and you just create a new spot and just add it to the topology by calling the set spot, giving the name of the spot, and that's it. And the spot is inside the topology. Same you do with the bolts, and then you define from which spots or bolts defined bolt will read the data from. So we just create a, just call the shuffle grouping. So because we just want to do shuffle, and specify the input spot for this bolt. Another defining the topologies in Java code is not very convenient. So there's a new library called Apache Flux, which enables you to define topology much easier in the YAML. So here it is. So here we define the name of the topology. This is the way we define the spots. Name, the class name for the spot, and some constructor arguments. Same for the bolts. Sorry. And for the streams, we just define from which node to which we want to pass the messages, and with what grouping. Again, very simple. But I know that many of you are just, I suppose, Python coders. How many Python coders do we have here? Okay. More than Java, I suppose. Sorry. So now, but you can use Python. You can even write full topologies, everything in Python. And here it is, the stream parse library, and that enables you to do it. So here's a very simple word count example, the simplest one which you can think about. So how you define the topology here? You just, this is very similar to Java, it's less code because it's Python. But the thing is that you don't have to write a single line in Java. One disadvantage is that this library is still in beta, so it's not very reliable. I had a lot of problems actually with doing it, but I'm sure that it will get better and better. Let's take a look how the bolts and spots looks like in Python, and as you can see, it's again the same API. Again, you have the next tuple, and you still just emit the new value. So it's very straightforward, very simple. Same with bolts. Also, you have just process, and you can emit the new tuple if you want. So very simple to use, very powerful, and I think you can think about many applications when you can use such analyzing. One thing I want to show you about that this is real time. Let's start again the Twitter topology. So let's start it. So now it's starting. Sorry for the lots of text, but it's Java, so you have to understand it. It just likes to talk a lot. So now it started, and now what I want to do, I want to go to Twitter. Now I'll tweet a new message with specified hashtag, and you'll see that it appears here. So let's go to Twitter, write something here, use the keyword. The keyword is Java. Sorry. But we can also use meet.ml, and just let's add a hashtag which we monitor. We monitor for hashtag test. Right, and let's now tweet it. Go to here. And go. Where it is? I think sorry, the typo. It should be J-A-V. Damn it. And hashtag, test, and tweet. And we have a new tweet from what the fuck is, so thanks. So as you can see, it's real time. I mean, the only delay is the Twitter itself. So as you can see, you can do some fun with it. You can monitor Storm, you can monitor Twitter, you can monitor Facebook, you can monitor everything you want. So I do recommend it. We've been here. So a few tips if you want to start using it. As I said before, the values in tuples must be serializable. Then, if one of the bolts will fail to process the tuple will be invalidated all the way up to the source, because Storm will make sure that every tuple is processed. If it's not, it's invalidated and go all the way up to the source. And if more than one bolt is subscribed to some spot, and the tuple will be invalidated, it will be invalidated both. So what's the risk of it? If we take a look here on this example, here we have the spot, and let's say that the tuple is duplicated here and goes to both of those bolts, and it will be would fail to process in this bolt. It means that it will be invalidated and it will be sent once again to both of them, and it will be processed here twice. You have to keep it in mind. Next tip for me is it's always good to have some kind of buffer before Storm, like Rabbit or Kafka queue. It really makes it all much easier. And the last tip, never use blocking methods in next tuple, because bolts and spots are single-threaded. If you use a blocking method in next tuple, the whole spot will just freeze. So it's not a good approach. Any questions from you?
Yeah, you mentioned that you can write all the thing in Python. Do you use on speed while doing this? Is it as efficient as Java?
So the question is, as I said, we can write that in Python, and the question is if it's as efficient as Java. The answer is I don't know, because the Python library is very immature. It's very new. I wasn't able actually to test it. Let's give it a while. Let's give the library the time to actually be the normal version, not the beta, and then I think we can test it. Any question?
I would have a comment on that. For example, in Spark, when you have implementation in Python and in Scala, actually in Java, then some parts which are directly written in Scala, like data frames, and are directly convertible, they have a very similar runtime. But for the things that are typically Python, for example, if you use some Python library in distributed job, then it will be much slower. So I guess with Storm, eventually it will become similar.
Any questions?
I understand you're using Storm at CurrencyOne. Can you say what kind of things you're using it for?
It's a very good question. I cannot answer. Sorry.
How you can do it?
But
Classify.
yeah, it's but I can say what are the possible approach, the possible uses. For example, as I mentioned, for the marketing. If we have a new client, or we know that this client is very interesting for us, we can immediately. There's a client, for example, who just registered, and we want to keep him with us. So we decide, okay, so he's interesting. He signed up for using the Google referral, so we want to send in this email usage, you set up a cluster of several servers, and you just run the topology remotely. So you just upload the topology to the cluster, to the Nimbus, and Nimbus will distribute the topology to the workers, the supervisors. So you can set up a large cluster for Storm, and it will just run remotely in the data center. And what is very important from the new version, from the 1.0, it's much more reliable, because before the 1.0 you had always one Nimbus node, and after the 1.0 you can have multiple Nimbus nodes, so it's much more reliable. Any other questions?
You had some fancy way to define topology other in JavaScript, other in Java. What was it?
You mean the YAML?
Yeah.
It's here. Yep. So
is it supported from some concrete version of Storm, or?
as far as I know, it's supported from 0.10. So for the very old actual version. The current version of Storm is 1.0.1. So it's supported for at least 6 months, I suppose. So yeah, that's answering the question.
Yeah.
Any other questions? Yep.
In your project, in which way are you defining the hashtags for which you are searching the tweets? I mean,
Here?
is it efficient to search the text only based on hashtags?
Here in this example, let me just maybe show where is the filter. So here is the filter which looks for hashtags, and what is cool about the Twitter? It gives you the very convenient usage, because you get the tweet and you get already all the hashtags extracted from the tweet. So it's very easy. When I get the, I can even show you. Here is the thing. So I get the wait a second, where's here it is. Yeah. So here's the tuple. We get the tuple here, and in tuple we get all the hashtags which are already defined here. Tuple here, yeah. So we get the list of hashtags which are in the tweet. We don't have to extract them by ourselves.
Yes, but my question was about the hardcode value, the hashtag for which we're looking from tweets.
Oh,
How do you define them?
so I defined them in the topology. So here it is. So it's just a configuration parameter of the filter bolt which are using. So here it is. I'm looking for the test and hashtag, and you have to define it hardcode in the topology configuration.
Yes, but how will you define it? I mean, based on what knowledge?
Oh, this is just an example. So I just wrote an example to show the possibility.
Yes, but in real project, are you based your analysis only on hashtags, or are you also analyzing all tweets?
I don't do the Twitter analysis in my job, to be honest. So it's just a simple presentation of what you can actually do with Twitter and Storm. Any other questions for you guys? Okay, so I think we're done. Thank you for